Okay, so let's summarize what we have when we're talking about infinite sum or series, right? So when it says converge or diverge, if convergent, find the sum. That's the last two that I just did. So that means it's going to be a geometric or a telescoping. A geometric sum means it's going to be numbers to the nth powers, and that's the best way, the easiest way is to write out the first three terms to find out the value of r. So if absolute value of r is less than 1 or greater than 1, tells you whether it converges or diverges. Okay, telescoping sum is when you're going to have a fraction that you'll be able to do a partial fraction decomposition on. So we're talking polynomials. And then remember, you'll always get a subtraction sign, put it in the middle, find the s sub n, and then once you find the canceling pattern, then that's your s sub n, and you're finding the limit of that sequence. So the sum is equal to the limit of the s sub n. So that's a summary of those two. Okay, so remember there's the p-test. So let me just go over the p-test again. The p-test we're going to use so often, I want you to actually be bored with it so that it's so straightforward and you recognize it so easily. So this here, power, nth third power, square root. So this power over root, rewrite this so you can see what the p is equal to. I see the p is equal to 3/2, which is bigger than 1. So you say converge by p-test. This one here, I could really pull these numbers on the outside so that you don't have to look at them or think about them, that you can just look to see, does this converge or diverge by the p-test? It does converge by the p-test because p is 4 greater than 1. All right, so let's rewrite this one as power over root. So that's squared power cubed root. This 2/3 power is smaller than 1, so this diverges by the p-test. This is the same thing if I pull that 3/2 out on the outside as just 1 over n. So let's go back up to the rules here. It says if the p is equal to 1, it diverges. So this diverges by the p-test. This one here, n equal 1 to infinity. This is the same as saying 3 to the 1 over n. Wait a minute. This is not the p-test. I keep going over this because I want to make sure you're really comfortable with this. I can't do the p-test on this. Remember, this is one we've done test for divergence on. So if I take the limit of the nth term, here I would get 1 over 3 to the 0. So that would give me 1. Since this doesn't equal 0, this diverges by test for divergence. Okay, this one here, this is the same thing. All this could be written as to the nth power. Wait a minute, that's not p-test. P-test has to be 1 over n to the p. The nth, not nth power. What is nth power? Nth power. Oh, that's geometric. So geometric is when I have a number to the nth power. So if I look at this, I can see that the a is negative 1 over e. The r is negative 1 over e. Does not say find the sum, does it? Doesn't say to find the sum. It just asks for converge or diverge. Since the absolute value of r is less than 1, this converges by geometric. Not necessary to find the sum. Just the converges by geometric is identified what the r is equal to. Sorry, that's kind of messy up there. That's just me pointing to the nth power. Converge or diverge. Okay, we can't use the p-test as it's written, so I need to separate this into two sums. So this first sum is 1 over n squared, and the second sum is 1 over n to the 4th. So they both converge by p-test because the p's are bigger than 1.